We are familiar with gradients. You might think you're not, but you are. There are gradients of altitude and elevation. And a gradient refers to 2 points in a physical space. So up here on this mountain here, the top of the gradient is the tip top of the mountain, and base camp is at the bottom of the mountain. So if you want to move from the top to the bottom of the mountain, it takes no energy. If this water wants to flow from the top to the bottom of the mountain, it takes no energy. You're going with the gradient. However, if you want to go from the base camp to the top of the mountain, that takes a lot of energy. If you want to walk up this creek bed, that takes a lot of energy. So we see that gradients can be set up in an effort to allow molecules to move in the body. We are also aware of thermal gradients, right? A thermal gradient is something that has temperature as its gradient instead of altitude. And molecules flow from areas where it is hot to areas where it is cold. And this is because in a hot area, molecules have a lot of energy. They move around a lot. They have this thermal energy. But as they dissipate, those into a cold area, the molecules start to move a lot more slowly. And this creates a gradient. What we're going to see in this class all the time are concentration gradients. In this picture up top, I seem to have a whole bunch of these hexagonal shaped molecules right here, and there's a lot of them out here outside of this cell, and there's not so many of them here inside of the cell. And so this is a gradient where there are lots of molecules in high concentration in one area, and not a lot of molecules in concentration in another area. And this sets up a gradient where molecules flow from a high concentration to a low concentration. I have a luscious cup of coffee here because if you put like the sugar and the cream on the bottom of the coffee and you don't stir it, it will take those molecules a while to move from an area where they're in a high concentration to a low concentration. And if you come back in a half an hour, you will have a homogeneous mixture of coffee. The milk and the sugar will be fully mixed within the coffee. We will see pressure gradients, not so much this semester, but a pressure gradient has one area that's under high pressure, like the blood in the heart when the heart is pumping. And there are other areas that have low pressure, like the veins in your body. A pressure gradient moves molecules, or in our case, blood, from an area where it's high pressure in the aorta to an area where there's low pressure in the veins. And that's what helps your blood flow. However, in your lungs and in your heart, just allowing that flow isn't enough. We usually have some physical pump in our body that is creating that area of high pressure. We will also see electrical gradients in our class. We'll actually see chemical electrical gradients, which is a combination of a concentration gradient and an electrical gradient. So, electrical gradients work this way. We have positive and negative charges. An electrical gradient doesn't care if you're a positively charged sodium or positively charged potassium. It doesn't care. It just knows that you have a positive charge. That's what it's concerned about. And charges will flow from an area where they are abundant to an area where they're less common. And in this picture here, you can see all of these orange colored positive charges, and they are moving into the cell, and they're moving from an area where they are abundant to an area where they are less common. Yes, the purple charges, the negatives, are probably moving the other way as well. We could assume that. Remember, though, with an electrical gradient that we might be concerned about the movement of positive cations, or we might be concerned about the movement of negative cations, right? It depends. We can look at the gradient either way by looking at its positives or negatives.